Hey guys, so in this video I'll be going through the 2014 integration paper for calculus, but I'll just do like the excellence questions. So yeah, let's get right to it. Okay, so question 1E. So show that the area between these two curves is a third, and we have two functions here. P is greater than 1. Okay, alright, so first thing I'm going to do is let's just like associate a function to each curve. So we know that the y squared is this one, and this quadratic is this one here. Um, Now the first thing we got to do is into this area problems, we got to find the lower and upper limits of our integral respectively, right? So we know that both graphs pass through the origin. They don't have a constant in them. So the integral will go from 0. Um, then we know that the integral will go from 0 to the point where these two curves intersect. So now rearranging this first equation will give y equals root px, and our second equation will be y equals px squared. Now setting these two equations equal and squaring both sides will give px. Okay, that's px is equal to p squared times x to the power of 4. Dividing both sides by px will give 1 equals px cubed. And so x is just going to be the cube root of 1 on p. So that is the x value of this point. That's when x is the cube root of 1 on p. Alright, so the upper limit of our integral will be the cube root of 1 on p. Right, cool. Now that we've found that, so what we need to do is I'll set up the integral now, right? So we're trying to find the area enclosed between the two curves. So I'm trying to technically just find the difference between the area of this upper curve, which is the square root px, and out of that I have to take the area underneath this quadratic out. So if we integrate this y squared function, we will find this entire area, right? But if you integrate this quadratic, you will find this area here. Therefore, if you subtract the two areas, um, you will find like this shaded region here. So setting up the integral means it will be, we can write area is going to be the integral from 0 to the cube root of 1 on p for root p times root x minus px squared. Pretty sure it's px squared. Yeah. And dx. Cool. And now what we can do is literally just integrate this. So we will get root p times 2 on 3 x to the power of 3 on 2. After you have to convert this to the power of a half. A half plus 1 is 3 on 2, and then 1 over 3 on 2 is just 2/3. Oh, sorry, this should be a minus, by the way. Minus, p on 3x cubed using the power rule for integration between 0 and the cube root of 1 on p. And now what we can do is sort of just write this in third form. That might make it easier. So root p times 2 on 3, the square root of x cubed minus p on 3 x cubed, right? Between 0 and the cube root of 1 on p. And now we can start our substitution process. So substituting x equals the cube root of 1 on p will give the square root of p times 2 on 3, and then x cubed is just 1 on p, so times the square root of 1 on the square root of p, or 1 on root p, right? Minus p on 3 times, now remember that x is the cube root of 1 on p, therefore x cubed is just 1 on p, and so times 1 on p, and then minus, and then if we sub in 0, then we'll just get this term will become 0, and we get 0 minus 0. And then doing the simplifications, the root p's will cancel out and the p's will cancel out. So we just get 2 on 3 minus 1 on 3, which is equal to 1/3. And that's how you do the first question. So yeah, that's question 1E proven. Now let's find the second excellence question. Okay, so the center of mass of an object is called the centroid, and for a uniformly thin object, the centroid is at x bar comma y bar, where x bar is 1 over the area of the object times the integral between a and b time of fx times f of x with respect to x, and this is y bar. Okay, okay, this is our function here between x equals 0 and x equals 4 and y equals 0. Oh, okay. Alright, so I think, okay, so the first thing we should write is just um, let y equal f of x, right? And so our first step should be to find this area, right? So area of this function here. So I'll just write finding a. So to work out a, let me just change my color. So our area is going to be, so a is going to be the integral from 0 to 4, because this is our function, root x plus 1, which spans from x equals 0 to x equals 4, of the square root of x plus 1, root x plus 1 with respect to x, and this will give us 2 on 3, x to the 3 on 2, plus x between 0 and 4, which will just then give us 2 on 3 bracket 4 to the 3 on 2 plus 4 minus, and then those two terms will just become 0, so 0 plus 0. And putting that in your calculator, 3 gives me 28 on 3. But both of these coordinates, to find them, they have 1 over a involved, so we can just write a statement, therefore 1 over a is equal to 3 on 28, and so we should box that. Cool, now that we've found that, now let's go ahead and start by finding x bar. So we'll start, just line this out over here. Okay, alright, so finding x bar. Now our equation for x bar was x bar equals 1 over a times the integral from 0 to 4. Or should I write 0 to 4 is fine. x times f of x, okay? For x times f of x with respect to x. So I could just substitute this then, I guess, for 3 on 28. Oops, what did I do? Okay, there we go. 3 on 28. And so now let's go ahead and just start putting things in. 3 on 28 times the integral from 0 to 4 of x times the square root of x. I'll put that in power form. X times x to the power of a half, plus x with respect to x. After doing the expansion, so you get x root x plus x. And so using the algebra rules, this will now we can just add the powers. So we can just get 3 on 28 times the integral for 0 to 4 or x to the power of 3 on 2, because this is x to the 1 plus a half is 3 on 2, plus x. And so now we can start integrating this. So we will just get 3 on 28 times x to the 3 on, oh no, we haven't even integrated it. Let's integrate that. So 3 on 2 plus 1. Okay. That's going to give us 2 on 5x to the power of 5 on 2 plus half x squared between 0 and 4. And evaluating that will be 2 on 5, 4 to the 5 on 2 plus a half of 16 will just be 8, so plus 8. Minus 3 on 28 bracket, and then this will go to 0, this will go to 0, 0 plus 0, and that will just become, if you put that in your calculator, 3 on 28, 2 on 5, plus 8. That gives me, okay, it's a bit of a weird number, but I got 78 on 35, which is equal to 2.23. So I'll just write like a statement. Therefore, x bar is at 78 on 35, which is equal to 2.23. I should just box that. Nice. Cool. Okay. Now let's find y bar. Alright, so I'll just box this once again nicely. And we're at finding y bar. And I know that the equation for y bar, I think, was 1 over a times the integral from 0 to 4, okay, so 3 on 28, times the integral of half of f of x squared, okay, half times root, okay, I could actually just take the half onto the other side, so I would just get, so I would just get, right, I'll just write down the equation fully, so 3, um, I think it's frozen, hold on. That's weird. Hello? Okay, there we go. Okay, sorry about that. Don't know why I did that, but okay. Anyways, so finding y bar, and our equation for y bar was 1 over a times the integral from a to b of half of f of x squared with respect to x, and then now taking the half to outside the integral, I'll just get is equal to 3 on 56, oops, on 56 times the integral from 0 to 4 of root x plus 1 squared with respect to x. And then expanding that will give me, so we'll get this term squared, so that'll just become x plus 2 root x plus 1 squared, a squared plus 2ab plus b squared with respect to x, which will just become 3 on 56 times half x squared plus 2 times 2 on 3 x, so that'll just become 4 x to the power of 3 on 2 plus x from 0 to 4, and let's continue the working out over here. So subbing the numbers in will give me 3 on 56 bracket 1/2 of 4 squared plus 4 on 3, 4 to the 3 on 2 plus 4 minus 3 on 56 bracket, this will go to 0, this will go to 0, and this will go to 0. So 0 plus 0 plus 0. And then putting this in my calculator, actually let's simplify it and tidy it up a bit. So we'll get 3 on 56 times, so 16 on 2 is just 8, 8 plus 4 is 12, so we get 12 plus 4/3, 4 to 3 on 2, putting that in my calculator gives 17 on 14, which is equal to 1.21. And so now that we've found y bar, I can just make a quick little statement. Therefore, the centroid is at, so x bar was 78 on 35, comma 17 on 14, which is also the same as 2.23, comma 1.21. And cool, so that's this second excellence question. Done. I think I've answered everything. Yep, let's move on to the next one. Okay, yep, alright, so, okay, we got a differential equation here. So, if a plant is grown at a constant temperature in a glasshouse, then the rate of growth of the plant would depend on the length of the day. So, we have this differential equation here. T is the time measured from the longest day of the year. Okay, so I just assume then that is T equals 0 days. Okay, so you have a growth constant on the longest day of a particular year. A plant has a height of, okay, on the longest day. So if when T equals 0, H would just be 84, and then when T equals 75, then H equals 91. And then what will the height of the plant be in the longest day of next year? So the longest day of next year will be exactly 365 days from T equals 0. Therefore, when T equals 365, find H. Okay, cool. Alright, now let's go back to that differential equation. Now, we have a K, which is a growth constant, and we have this trig function in here. So let's go ahead and separate the variables. So if we divide both sides by k, then we'll get 1 on k with respect to height is equal to 12 plus 3 cosine of 2 pi t on 365 dt. Cool. Now let's go ahead and integrate both sides. So just write integral symbol to get rid of the dh. You should just also keep in mind that this won't actually become ln of k because you're integrating with respect to height. So actually this would just become h times 1 on k, or h divided by k is equal to integral of this. So that would become 12t plus, so 3 times 1 over the derivative. So the derivative of 2 pi on 365 times time would just be 365 on 2 pi. And the integral of cosine is sine of the same angle, 2 pi time on 365 plus c. Cool. Okay. We can tidy this up a little bit, I think. So h on k is equal to 12t plus 3 by 365 is 1095 on 2 pi sine of 2 pi t on 365 plus, plus c. Alright, so I think we can now go ahead and sub in this first point, t equals 0, h equals 84. When t equals 0, h equals 84 centimeters, so we can now substitute these back. So 84 on k is equal to, this will go to 0, and sine of 0 in radians is just 0, so this will just become 84 on k equals c. Okay, alright, so we've got this condition here. So I think we could rewrite the equation, right? So now, we can write h on k is equal to 12t plus 1095 on 2 pi sine of 2 pi t on 365 plus 84 on k, substituting for c equals 84 on k. Cool, so what's our next point? When t equals 75, h equals 91. T equals 75, so when t equals 75, h equals 91. Let me just double check. Yep. Alright, now let's just substitute the numbers in again, because this time we've already got we've got h, we've got t, so we'd actually find the growth constant for the plant. So let's go ahead and find the growth constant. So I will get 91 on k, and actually I'll just take this 84 on k to the other side, minus 84 on k is equal to 12 by 75 plus 1095 on 2 pi sine of 2 pi on 365 times 75. Alright, cool. So 91k minus 84k, so that's 7k on k squared is equal to, what's this, 12 times 75, 900, plus, now let's put this into our calculator. Make sure it's in radians because we're dealing with pi here, so and that gives me 900 plus 167.5. And so simplifying this, I'll get 7 on k is equal to 1067.5. Therefore K would just be 7 on 1067.5, which is also equal to, so 7 on, that is 6 point, okay, that's a small number, 6.56 times 10 to the minus 3. Alright, cool. Now that we've got our growth constant K, oh, okay, cool. So we've got everything we kind of technically then need, right? Yeah. Okay, cool. Question number 3 and E. So let's go back and copy our stuff down. So where is our equation here? Our handy little equation. Cool, so H on K. So we know that H on K is equal to 12t plus 1095 on 2 pi, 12t plus 1095 on 2 pi, sine of 2 pi t on 365, plus 84 on k. Cool. Where k equals 6.56 times 10 minus 3, and t equals 365. And h equals what? So now let's go ahead and plug in the numbers. So we'll just get h on 6.56 times 10 minus 3 is equal to 12 times 365 plus 1095 on 2 pi, sine of 2 pi times 3, sine of 2 pi plus 84 on k, and sine of 2 pi, that's just 0, so we will get h on, sorry, is equal to, this term will just go to 0, so 4380 plus 84 on 6.56 times 10 minus 3. And so multiplying both sides by the growth constant k, I get h equals 6.5. Actually, I'll use a more accurate version, which was 7 on 1067. 7 on 1067.5, bracket 4380 plus 84 on 6.56 times 10 minus 3. Putting this all in my calculator gives me height equals 112. Oh god. 112.7 centimeters. Which, yeah. So yet I get 112.72 centimeters. So yeah, I could just put that into words. Therefore, on the longest day of the following year, the plant will be 112.7 centimeters high, according to this differential equation. So yeah, And that is all three excellence level questions done. Yeah, so thanks for watching. Bye.